Sylvania, the fastest growing name in sight. In the early morning at Sylvania's Drummondville plant, things are peaceful. Perhaps a truck making an early delivery, a few parked cars belonging to night staff, a watchman making his rounds as he guards this building. One of two in the Sylvania Drummondville operation, the newest and best equipped lamp plant in Canada. Peaceful now, but soon to swing into action as the day shift starts to arrive on the job, ready for the day's work. At Sylvania Drummondville, some 300 men and women work in the precision business of producing thousands of incandescent bulbs, fluorescent lamps, and flash bulbs each day. A production figure that is increasing steadily in line with the ever-growing demand throughout Canada for Sylvania products. Produced by Canadian men and women such as these, operators and technicians. From this Sylvania Drummondville plant come the lamps that we depend on day in, day out for our illumination in business and home. For the familiar incandescent lamp, the intricate and exact process starts here in the incandescent area, at this machine maybe, or at one of the many other similar machines in the surrounding area. This machine is fully automatic, carrying out the many delicate operations necessary for the production of a first quality lamp. First, glass tubes for the filament stems are fed in and mechanically molded under heat. Then are added the lead-in wires, the supporting wires, and finally, most important of all, the tungsten filament, the heart of the incandescent lamp. All these operations this machine carries out automatically without risk of human error. And now the filament mount and the glass outer envelope come together. The components are positioned, cemented precisely in this fully automatic operation, the last of the series of processes being that of soldering and on-off testing. And now we see both ends of this operation. The girl in the foreground is feeding in the components. The girl on the left is taking off the finished lamps and pre-testing them manually before packing them in their sleeves. Just one example of Sylvania's continuous quality control. And here in another section of this multi-million-dollar plant, we find the fluorescent lamp division. The basic units, the untreated tubes, are first steam washed to ensure that they are entirely free of dust or dirt. The phosphor coating is pre-mixed in these centrifugal vats, kept running 24 hours a day. The technician checks constantly on viscosity to ensure that when the coating is applied, it flows evenly, giving a uniform coating controlled by Sylvania to micrometric tolerances. The production of the phosphor itself is controlled too by Sylvania, right from the basic chemical components to the final stage of application. Immediately after this application, the tubes pass into the dryer where they are dried under medium temperature heat in preparation for the baking process. Traveling up the conveyor, the tubes first pass the etching machine, where identification and the famous Sylvania trademark are stamped on them. Then passing through the oven, where the phosphors are baked in, they are carried out over the special cooling rack, and finally down to the illuminated inspection table. And there the operator is waiting to examine them. After inspection for uneven phosphor coating, one of the many points at which Sylvania quality control is carried out, the coated tubes are ready to receive the mounts carrying the cathodes. And here you see the various machines which coordinate to bring all the components of the lamp together. For the cathode mounts, the glass components are fused together, the lead-in wires and tungsten coil are sealed in. The coil is dipped into the special cathode coating of calcium, barium, and strontium carbonates. Then the entire assembly is treated with zirconium oxide, a process pioneered by Sylvania to give clearer, brighter burning lamps. Then in the Silex machine, tubes and mounts are fused together, and the tubes, as in the incandescent process, are made ready for exhausting and filling. They are then transferred to a high temperature control conveyor before reaching the horizontal exhausting and flushing machine. A revolutionary new machine designed and built by Sylvania for Sylvania, this machine actually flushes the tubes with argon, forcing air out, and then fills them with argon and mercury. The lead wires are welded to the metal end cap, and the tubes pass the aging rack, and through a quality checkpoint where they are tested for reliable starting, the occasional reject being automatically discarded. The process is almost complete. A last inspection by the operator for correct base and pin alignment, and the Sylvania fluorescent lamp is ready for packing and shipment. And we move across town to the Sylvania flashbulb plant. First, we see the glass envelopes receiving their inside lacquer, a special Sylvania formulation which protects the glass from fragmentation. Then the glass envelopes are passed to this machine for filling before the mounts are added. Passing along the conveyor, the famous Sylvania blue dots are then applied. And the aluminum or zirconium foil is blown in. The quantity of foil is measured exactly for precise lumen output of flash. Meanwhile, the mounts with stem and fuse wire are assembled, traveling along to join the filled glass envelope. The two components are put together and then are transferred to a machine where they are exhausted and filled with oxygen. The oxygen which, on flashing, permits the aluminum or zirconium to burn with instantaneous brightness. One of the final steps is the application of solder, each base receiving the precise amount of solder for proper contact. Finally, the assembled bulbs come from the machine, are checked individually by the operator, and then loaded on the racks in which they are taken for lacquering of the outside. Here, this protective outside lacquer coating is being applied. In the case of regular flash bulbs, the coating is crystal clear. For blue flash bulbs for use with colored film, this lacquer is tinted to the precise shade of blue to ensure perfect color correction. After dipping, the flash bulbs are dried on special racks and taken for checking before packaging. This quality control is carried out by Sylvania throughout production. Here, for example, the precise weight of a foil sample is checked to a fraction of a micromilligram. And here, a technician is testing for precise flash timing action. At all times, samples of all types of lamps from the production line are being constantly tested by Sylvania's Quality Control Laboratory. This, for example, is the spherical photometer in which fluorescent lamps are tested at intervals during the life of the lamp to ensure that they meet the rigorous requirements of Sylvania standards, unmatched in the lighting industry. These lamps are taken from production line and from the life testing racks where production line lamps, both fluorescent and incandescent, are tested continuously under varying conditions to ensure that the Sylvania product is the finest obtainable. Constant quality control, high precision automatic machinery, the finest of materials, and the conscientious work of employees such as these now on their way home. This is the story of Sylvania Drummondville. This is the story of Sylvania quality.